Hello friend, we are going to learn today vectors and scalars. In description box you can find high quality ebooks and handwritten notes. So what is scalar? The physical quantity which has a magnitude but no specific direction is known as scalar quantity. Some example: distance, mass, speed. What is vector? The physical quantity which has a magnitude as well as direction and follows the vector law of addition, such as force, velocity, displacement, momentum. Note: current is not a vector quantity, though it has a direction and magnitude, as it does not follow vector law of addition. Representation of a vector quantity. A vector is represented by drawing an arrow proportional in length to the physical quantity being represented. That is, a vector variable is represented by an arrow over English or Greek alphabet. The same alphabet without the vector sign represents the magnitude of the vector, and the same alphabet with a cap sign represents the direction of the vector. Some examples: sine 2 pi by 3 is equal to square root of 3 by 2, cos 5 pi by 6 is equal to minus square root of 3 by 2, tan 3 pi by 4 is equal to minus 1, tan 2 pi by 3 is equal to minus square root of 3. Triangle law of addition. It states that to add two vectors using triangle law, place the tail of the second vector on the head of the first vector. Now complete the triangle and the resultant vector is given by the arrow starting from the tail of the first vector to the head of the second vector. In this figure, first vector is this and second vector is this, so the resultant vector is this. Okay, we take some example. A vector is equal to 3, B vector is equal to 4, and C vector is this, which is a resultant vector, and it makes an angle theta with a vector A. So we can write C vector is equal to A plus B, where theta is tan inverse 4 by 3. For example, if A is equal to 1 kilometer north, then A is equal to 1 km and A unit vector is a knot. Inverse trigonometric notation for angles. Sin inverse x represents an angle whose sine is x. Some example: tan inverse x is equal to tan inverse 1 is equal to 45 degree. Similarly, sine inverse half is equal to 30 degree. Now, radian measure of an angle. 360 degree is equal to 2 pi radian. So, if the radian angle theta of an arc is expressed in radians, then the arc length is simply L is equal to R theta. Trigonometric ratios for angle greater than 90 degree. So sin pi minus theta is equal to sin theta, cos pi minus theta is equal to minus cos theta, tan pi minus theta is equal to minus tan theta, sin pi plus theta is equal to minus sin theta, cos pi plus theta is equal to minus cos theta, tan pi plus theta is equal to tan theta. Note, here if A to B is equal to 4, B to C is equal to 3, and A to C is equal to 5, and AC is making an angle 37 degree with AB. So we can write sin 37 degree is equal to 3 by 5, cos 37 degree is equal to 4 by 5, sin 53 degree is equal to 4 by 5, cos 53 degree is equal to 3 by 5. Note, vector sum is commutative, that is we can write A plus B is equal to B plus A. Now angle between two vectors. The angle between two vectors is defined as the non-reflex angle between the vectors when they are joined tail to tail. Example, the angle between the vectors is 60 degree, as A vector is making angle with B is 120 degree. Now here you can see A vector and B vector making an angle 60 degree, so its outward angle is 120 degree. Now analytical addition of vectors. When we consider two vectors A and B represented for finding the resultant A plus B using the triangle law as was shown in the figure. So here this is A vector, this is B vector, and this is C vector, that is resultant vector making an angle phi with A, and theta is the angle between A and B as a outer angle. Now we can draw a perpendicular on extended A vector, and this is B sin theta and this is B cos theta. So we can write using Pythagoras theorem, resultant vector's magnitude is equal to square root of A plus B cos theta whole square plus B sin theta whole square. So C, magnitude of C is equal to square root of A square plus B square cos theta plus 2AB cos theta plus B square sin square theta. So magnitude of C is equal to square root of A square plus B square plus 2AB cos theta. Now the direction is given by phi is equal to tan inverse B sin theta by A plus B cos theta. Now we can practice some example. If this is our A vector which have a 5 units length, and this is our B vector having 5 units length and 45 degree angle between A and B. So the resultant vector using Abbott's law, we can write square root of A square, that is 25, plus B square, that is 25, plus 2AB cos theta, that is 50 into 1 by square root of 2. If we simplify this, we get square root of 50 into square root of 2 plus 50 by square root of 2, and the angle phi tan inverse of 5 by square root of 2 plus 5 plus 5 by square root of 2. Okay, and after simplifies, phi is equal to tan inverse 1 by square root of 2 plus 1. Now second example, if a man walks 10 km towards east and then another 10 km towards 60 degree northeast, find its resultant and direction. So this is our figure, 10 kilometers making an angle alpha and this is our north direction, which is an angle 60 degree with the east. So resultant vector C is equal to square root of 200 plus 200 into half, that is 10 square root of 3. You can also use above formula of resultant vector. And the angle alpha is equal to tan inverse 5 square root of 3 by 10 plus 15. So alpha is 30 degree. Now parallelogram law of addition. Here we replace the vector's tail to the tail and complete the parallelogram. Now the resultant is given by diagonal of the parallelogram passing through the common tail. So this is our A vector, this is our B vector, and this is our resultant vector C, which is A plus B. Okay. Note, for any vector A, the symbol A and the magnitude A mean exactly the same thing. Okay. Now the polygon law of addition. Here we join all the vectors to be added in a head to tail configuration, and now the resultant is given by the vector joining tail of the first vector to the head of the last vector. So if we have A vector like this, B vector like this, and C vector like this, and if we join like this A, B, C, this vector represents a resultant vector. Okay. This is nothing but a repeated application of a triangle law. Negative of a vector. What does signifies it? Negative of a vector is a vector with the same magnitude but with reversed direction. That is, if A vector is equal to 1 unit north, minus A vector represents 1 unit south. Subtraction of a vector. Subtraction is as the addition of the negatives. So if C vector is equal to A minus B, we can write C vector is equal to A plus minus B. If this is our A vector and this is our B vector, so we can write according to this figure, which is this is A vector, this is minus B vector, so C is equal to A minus B vector. So magnitude of the C vector is equal to square root of A plus B square, A square plus B square plus 2AB cos 180 degree minus theta, or C vector is equal to square root of A square plus B square minus 2AB cos theta. Now what is unit vector? A vector having magnitude and some specific direction is called unit vector. It is unitless. That is, any vector divided by its magnitude gives the unit vector in the same direction. Such as if A is equal to 5 km north, so A magnitude is equal to 5 km. So unit vector is A vector by magnitude of A, that is 1 unit along north. Now what is rectangular components of a vector? Whenever a vector is expressed as a sum of two mutually perpendicular vectors, then we call the vectors as a rectangular components of the vector. Okay. There are infinite ways of doing this. To resolve a vector into mutually perpendicular components, imagine a rectangle where diagonal is the given vector. The sides of such rectangle are the rectangular components. For instance, let there be a force F inclined at an angle theta with the horizontal. That is, this is our force and which is inclined at angle theta with horizontal component, that is this. So we can write from this its horizontal component fx is equal to f cos theta and its vertical component fy is equal to f sin theta. So we can easily divided a vector into two components as its horizontal component and as its vertical components. Now some examples. Suppose a block is like this, which has a force in this direction which has magnitude 300 Newton, and this is the inclined plane which is making an angle 30 degree with the horizontal. So weight in the parallel direction is mg sin theta, that is 300, and mg is value, and sin theta, that is sin 30, 1 by 2. So it is 150. And weight in perpendicular direction mg cos theta, that is 300 into square root of 3 by 2, that is 150 into square root of 3. Now second example like that a circle is moving in this plane making an angle 37 degree with vertical axis. If we consider like it as in direction of y and this direction is x. So in perpendicular to the thread is equal to 100 into 4 by 5 is equal to 80 Newton, or perpendicular to the thread, sorry, this is parallel to the thread and this is perpendicular to the thread, is equal to 100 into 3 by 5 is equal to 60 Newton. In example 3, if this circle is making an angle with this component or this axis 37 degree, then we can write perpendicular to the this axis 1000 into 4 by 5, where 1000 Newton is its weight or mg, and parallel component is 1000 into 3 by 5, so it is 600. Now what is unit vectors along coordinate axis? Any vector, say vector A, drawn in the xy plane can always be written in terms of its component parallel to the x and y axis respectively. So if this is our axis x and this is our y axis and this is our negative x axis and this is our negative y axis, so we take unit vectors along positive x axis is plus I cap, unit vectors along positive y axis is j cap, unit vectors along negative x axis is minus I cap, and unit vectors along y axis is negative j cap. So we can write a vector A as ax I cap plus ay j cap. This figure is in 2D. Okay, such representation is called Cartesian representation. Now in this figure or example, if a vector 5 is equal to 4 I cap plus 3 j cap, so how can we draw this? This is 4 I cap, that is in I direction or x-axis, along x-axis. Its magnitude is 4. Along y-axis or j cap direction, its magnitude is 3. So the vector is 5 unit along this. Okay, and it's making an angle 37 degree. In the latter case, if a vector represents like 10 is equal to minus 10 cos 30 I cap minus 10 sin 30 j cap, or we can write like that, minus 5 I cap minus 5 square root of j cap. So we can easily draw this figure from this. Okay. Now polar representation of a vector. So when a vector is specified in terms of its magnitude and angle which it makes unit with the x-axis, we call it polar representation. Suppose a 10 at the angle of 30 degree. So with x-axis, this is our vector 10 making an angle 30 degree. So its radius, we can say r is equal to 10 and its angle is 30. So its polar representation is like r cos 30 degree. Okay. Now what is converting from, or what are the relation between polar and Cartesian form of a vector? Consider a vector r having a magnitude r making an angle theta with x-axis as shown in the figure. So this is our vector r which is making an angle theta with the horizontal component or the x-axis. So we can write small r vector is equal to r cos theta I cap plus r sin theta j cap. Representation of the polar vector with Cartesian. If v is equal to minus 5 I cap plus 5 square root of 3 into j cap, so we can write minus 5 as 10 cos 120 degree I cap plus 10 sin 120 degree into j cap. So if we put these values, we can back minus 5 and from this 5 square root of 3, and this is the representation. Now the principal ranges for inverse function. We know sine inverse is equal to minus 90 degree to 90 degree, tan inverse is equal to minus 90 degree to 90 degree, and cos inverse is equal to 0 degree to 180 degree are the ranges. Now converting from Cartesian form to polar form. So consider a vector A as represented in the Cartesian form like this. A vector is equal to ax I cap plus ay j cap as shown in the figure. So this is our A vector and this is our x-axis, this is our y-axis. So this component is ax and this component is ay. So A or magnitude of A is equal to square root of ax square plus ay square, or tan theta is equal to ay by ax from this figure. Okay, if this is our angle theta. So theta is equal to tan inverse ay by ax if ax is positive, and theta is equal to 180 degree plus tan inverse ay by ax if ax is negative. Now convert the following from Cartesian to polar forms. So if we have 3 I cap plus 4 j cap, we can write this 5 at the rate 53 degree. If b is equal to minus 4 I cap plus 3j cap, we can write like this. And if c is equal to minus 3 I cap minus 4j cap is equal to 5 and at the rate 233, and d is equal to 4 I cap minus 3j cap, we can write like this. Now addition of vectors in Cartesian form. Let a and b be the two vectors given by a is equal to ax plus ax I cap plus ay j cap. B vector is equal to bx I cap plus by j cap, represented for addition by triangle law in Cartesian plane as shown. So this is our x, this is our by. So we can write ay like this and bx like this. So this is a and this is b, and a vectors component ax and ay, and b vector components bx by. So if we add like this, c is equal to a plus b, so this thing represents cy component and this whole thing represent cx component. So we can write, let c be the resultant given by c is equal to cx I cap plus cy j cap. Then it is evident from the figure that cx is equal to ax plus bx and cy is equal to ay plus by. For example, a is equal to 3 I cap minus 4 j cap, b is equal to 4 I cap plus 8 j cap. So a plus b is equal to 7 I cap plus 4 j cap as simple addition. Now we are interested to know a position vector which is represented by capital R cap or R vector. To represent the location of a point in a space, we need a third coordinate called the z component or z coordinate, which represents the height or depth over the xy plane, which we need to travel to the reach that desired point. This is called the z direction. The unit vector along this direction is z cap or r cap. So in 3D, if we have x, y and z, as you can see, this is a cube and this is our initial point, which is a coordinate 0 0 0, that is x is equal to 0, y is equal to 0 and z is equal to 0, and this is a, b, c, d, e, f, g. Okay, so from this figure, if we take this length or this height as 4, this breadth is 1 and this length is 6, so from this figure we can easily find a, b, c, d, e, f, g like this. Okay, so in space or in real 3D space, we need 3 components to represent a vector. Now position vector. What is position vector? The position vector of a point in space is defined as the vector joining the origin to that point. Example, rg is equal to 6 I cap plus 4 j cap plus z cap or k cap. Okay, we can write this as also k cap. Okay, this is also you can write as z cap or k cap. Okay, magnitude of a vector in 3D. So what is the magnitude of a vector 3D in 3D? So if this is our vector and this is from initial point and this is our final point, then we can write using triangular law OC square, that is this O and C, and its base is OB, so we can write this path, and this is RPC. Okay, so OC square is equal to OB square plus BC square. Now we can split OB square is equal to, that is our OB square is equal to OA square plus AB square. Okay, now finally we can write OC square is equal to OA square plus AB square plus BC square, or A square is equal to X square plus AY square plus AZ square, or magnitude of A is equal to square root of AX square plus AY square plus AZ square. Now direction cosine of a vector, how we can represent? The cosine of the angle that a given vector makes with XYZ axis respectively is known as the direction cosine of a vector, and these are cos alpha, cos beta and cos gamma are called direction cosines. So what is alpha, beta and gamma? So alpha is the angle of a vector making with x-axis, beta along y-axis, or gamma along z-axis, or we can change this alpha, beta, gamma according to your figure, any figure. So if we draw this cube, and then angle CEO has CEO has angle CEO is equal to 90 degree. So cos alpha is equal to OF by OC, OF by OC. Okay, okay. Or we can write AX by AX square plus AY square plus AZ square is equal to AX by A. So we take AX, AY and AZ along X, Y and Z axis respectively. So like this we can also write cos beta is equal to AY by A, cos gamma is equal to AZ by A. So there are two properties. First one, cos square alpha plus cos square beta plus cos square gamma is equal to 1, and sin square alpha plus sin square beta plus sin square gamma is equal to 2. Now multiplication of a vector by a scalar. Whenever a vector is multiplied by a scalar, the magnitude gets multiplied and the direction remains same. If it is a positive scalar, and direction reverses if a scalar is negative. So if f is equal to 6n east and t is equal to 3 second, so this is our vector and this is our scalar. So f into t is equal to 18 north second east, 18 Newton second in east, or minus 18 Newton second in west. Okay. Now what is displacement vector? If a particle moves from one position to another, then the change in its position vector is called displacement vector. That is S is equal to RV minus RI, where RV is the final position vector and Ri is the initial position vector. Okay, in this figure, if S is equal to 12 I cap minus 4 j cap minus 3 k cap, so we can write Ri is equal to 4 j cap plus 3 k cap, and Rf is equal to 12 I cap, like this. This is our x, this is our y, and this is our z. So S vector is equal to Rf minus Ri. Okay. So 12 I cap minus 4 j cap minus 3 k cap, or magnitude of s is equal to square root of 12 square plus 4 square plus 3 square is equal to 13 m or 13 meter. Now dot product. What is dot product of a vector? Or we can say it as a scalar product. Let there be a two vectors a and b having an angle theta between them. Then we define their product as d is equal to ab cos theta, or we can simply write like this: dot product a dot b. This is dot. Okay, so this is our a vector, this is our b vector, making an angle theta. So we can write a dot b is equal to ab cos theta. Okay, so take an example: a dot b is equal to 12 cos 35 degree, or we can write 48 by 5. Okay, so dot product has some properties. I dot I is equal to 1, I dot j is equal to 0, j dot j is equal to 1, j dot k is equal to 0, k dot k is equal to 1, k dot I is equal to 0. So why I dot I is equal to 0? So if this is our I cap vector and another I cap vector is like this, and these are parallel to each other, so angle between them is 0 degree. So I dot I is equal to I magnitude of I cos 0 degree. So magnitude of I is 1 into 1 into cos 0 degrees 1. So I dot I is equal to 1. So why I dot j is equal to 0? If this is our I unit vector, and where it is, this is our j unit vector, and we know the angle between them is 90 degree. So we can write I dot j is equal to I cap magnitude, j cap magnitude, and cos 90 degree. So the value of cos 90 degree is 0. So I dot j is 0. Note that dot product is distributive, that is a dot b plus c is equal to a dot b plus a dot c. Dot product is also commutative, that is a dot b is equal to b dot a. Suppose now we have two vectors a and b given by a vector is equal to ax I cap plus ay j cap plus az k cap, and b vector is equal to bx I cap plus by j cap plus bz k cap. Then a dot b is equal to ax bx plus ay by plus az bz. Now the angle between two vectors, we know that a dot b is equal to ab cos theta. So cos theta is equal to a dot b by ab, or theta is equal to cos inverse a dot b by ab. Now a is 5 square root of 3 I cap plus 5j, and b is minus 6j. So you can write a dot b by ab is equal to cos theta, or if we put these values, we can find theta is equal to 120 degree. Second example, if a is equal to I cap plus j cap plus k cap, and b is equal to minus I cap minus j cap plus square root of 2 k cap. Now using this we can find theta is equal to this. Now what is zero vector? A vector whose magnitude is 0 and direction is arbitrary. We can call this type of vector as a zero vector. Now the condition for orthogonality or perpendicularity. First condition, two vectors are perpendicular if their dot product is 0. And second condition, if the dot product of two non-zero vectors is 0, then they are orthogonal. So now if A is 3 I cap minus 2 j cap, B is p I cap plus q j cap, they will be 0, they are perpendicular, and the magnitude of V is equal to square root of 13. And how we get this? We get the dot product is 0 if they are perpendicular. So if we doing this, we can find 3p minus 2q is equal to 0, that is A dot B, and 3p is equal to 2q, and square root of this is equal to 13, and finally we can find p is equal to plus minus 2 and q is equal to plus minus 3, and then we can verify this and this. Okay, now the relative position vector. Let there be 2 points in space A and B whose position vectors are given by RA and RB, and this is point A, this is point B, and this is our initial point or origin, and this vector is RA and this vector is RB. Then the position of B as seen from A is defined as a vector joining A to B, which is also called position B relative to A, that is R B to A. As it is clear from the figure, position of B relative to A, we can write RBA is equal to RB minus RA. Now if we have RG, RC, RA, RCG and RAG, find angle between GA and GC. Okay, so this is our cube, this is our origin, this is A, B, C, E, F, G, and this is along x-axis, this is along y-axis, this is along z-axis. So RG is equal to 2 k cap, RC is equal to 2 I cap plus 2 j cap plus 2 k cap. So RC is this. Okay, and to reach the point C, we have to take 2 unit along I cap, 2 unit along j cap, and 2 unit along k cap. RA is equal to 2 j cap. We can reach along y-axis. Okay, only y-axis, using only y-axis, 2 unit along y-axis. And RCG is equal to 2 I cap plus 2 j cap. RAG is equal to 2 j cap minus 2 k cap. Angle between GA and GC is equal to 4 by 2 square root of 2 into 2 into square root of 2. So cos theta is equal to half and theta is equal to 60 degree. Now find the angle between body diagonals of the cube. So if we look at the body diagonals, we can easily find, if we look body diagonal, we can easily find OC is equal to 2 I cap plus 2 j cap plus 2 k cap, and GB is equal to 2 I cap plus 2 j cap plus minus 2 k cap. So OC dot GB is equal to 1 by 3. Here we can see that RAG is equal to GA, okay, which is starting from G to A. Now projection of a vector on another vector, that is component of a vector. Let there be two vectors, vector A, vector B, represented by length OA and OB. Then projection of A on B is obtained by joining the two vectors from tail to tail and dropping a perpendicular from head of A on vector B say point A prime. Now O A prime is the projection as it's shown in from the figure. Okay. You can use or you can refer to this figure. So projection of A on B is equal to A cos theta, or A is equal to A dot B by AB is equal to A dot B by B, or A dot B by B, or A dot B cap. So similarly, projection of B on A is equal to B dot A cap. Now cross product of vectors. Let there be two vectors A and B having an angle theta between them. Then their cross product C is given by C is equal to A cross B, and magnitude is given by C is equal to AB sin theta, and also a direction, and the direction is given by right hand thumb rule or the right hand screw rule. So what is right hand screw rule? Join the vectors to be crossed tail to tail and rotate a screw at the junction of the common tails from first vector to the second vector through the non-reflex angle. The direction of the rotation of the screw is the direction of the cross product. Now what is right hand thumb rule? Place the palm of the right hand perpendicular to the palm of the vectors such that the little finger is along the first vector and the curl of the fingers points towards the other vectors through the non-reflex angle. Now the thumb gives the direction of the cross product. Okay. Here we can take a note. Base of the palm or wrist should be at the common tail. Now cross product in Cartesian form. Here I cross I is equal to 0, I cross j is equal to k cap, j cross j is equal to 0, j cross k is equal to I cap, k cross k is equal to 0, k cross I is equal to j, j cross I is equal to minus k, r cross j is equal to minus I, and I cross k is equal to minus j. So why I cross I is equal to 0? So we can write like this: I magnitude sine. What is the angle between these two I vectors which is perpendicular to each other? Is 0. So sine 0 value is 0. And y I cross j is equal to k cap. So we can write I cap cross j cap like this: I j. The angle between these is sine 90 degree. So I j is equal to 1. And due to the direction n cap, which represents along z axis or k cap, so we can write I cross j is equal to k cap, and this is using right hand thumb rule. Note: cross product is not commutative, that is A cross B not equal to B cross A. Here A minus is out, and second cross product is distributive, that is A cross B plus C is equal to A cross B plus A cross C. Now the matrix method for cross product. Let there be two vectors is given by A is equal to AXI cap plus AY j cap plus AZ k cap, B is equal to BXI cap plus BY j cap plus BZ k cap. By multiplying this, you can write like this or in a matrix form: I cap, j cap, k cap. we take here minus, or you can also use a standard matrix form, and here we put the component of A along I cap ax, along j cap ay, along k cap, that is az, component of B bx along I cap, by along j cap, and bz along k cap. And simply we can multiply this using matrix multiplication. We get A cross B is equal to I cap into ay bz minus az by plus j cap az bx minus ax bz plus k cap into ax by minus ay bx. Note, if two vectors are parallel, then this cross product will be 0, or we can write ax by bx is equal to ay by by is equal to az by bz. And if two vectors are anti-parallel to each other, that is a vector like this and another vector like this with equal magnitude and opposite direction. Now, what is Lamin's theorem? Condition for equilibrium. A body is said to be in equilibrium if the vector sum of all the forces acting on it is 0. Okay. Now, what is sine law? If we have a triangle and it represents, this is our A, this is our B, and this is our C, and the height of the triangle is h, so you can write A by sine capital A is equal to B by sine capital B is equal to C by sine capital C. Okay. And this angle capital A is represents this angle. This is our C and this is our B. And we can also prove if AP is equal to AB sin B and AP is equal to AC sin C, so C sin B is equal to B sin C, or C by sin C is equal to B by sin B. Here we can also write the statement of Lamin's theorem. Let a particle or a body be in equilibrium under the influence of three forces Fa, Fb, Fc arranged tail to tail. Then, and this is our Fa force, this is our Fb force, and this is our Fc force, and they are all connected to tail, and making an angle alpha, beta, and gamma with each other. So you can write Fa by sin alpha is equal to Fb by sin beta is equal to Fc by sin gamma. And here are the proofs. As the resultant force is 0, closed triangle will be formed. So we can draw like this. This is our B, this is our C, this is our A, this is our Fa, this is our Fb, and this is our Fc. And the outer angle, this is our alpha, this is beta, and this is gamma. So you can write Fa by sin A is equal to Fb by sin B is equal to Fc by sin C using this theorem, Lamin's theorem. Okay. Now Fa is equal to sin 180 degree minus alpha is equal to Fb is equal to sin 180 degree minus beta is equal to Fc by sin 180 degree minus gamma, or Fa by sin alpha is equal to Fb by sin beta is equal to Fc by sin gamma. And here is a simple problem. If T1 is equal to this, T2 is equal to this, and T1 making an angle 37 degree with a horizontal axis, and T2 making an angle 53 degree with this axis. So what will be the net force along this? direction, so we can take 100 Newton along this direction force, okay, and which is perpendicular to this axis. So T1 by sine 337 degree is equal to T2 by sine 53 degree is equal to 100 using Lamin's theorem, or T1 into 5 by 3 is equal to 100, or T1 is equal to 20 into 3, T1 is equal to 60. So we can find also T2 is equal to 80. So for now, this is our first chapter. You can ask any question in comment box if you have any doubt or any question or any queries. So in next videos we will be discuss another chapter. For now, this is the end.